Okay, students, let's go ahead and make some sense out of that video we just watched. So we just saw that guy talk about Ohm's law, and he was telling us that voltage is equal to current times resistance. V equals IR. Now, he showed us some algebraic ways of getting, I by itself by, by doing different things. The method I like to do, and I'd encourage you to write this down in your notes, is I make this triangle shaped like that, and on top I write the letter V. Down the bottom I write the I, and on the lower right hand corner I write the R for voltage. Now I could solve for any of these variables really easy, super easy. If I want to solve for current, for example, I just put my thumb on top of the current, on top of I, and I'm left with V on top of R. V on top of R. So I just write that out. I put V on top of R, and I'm left with current equals voltage over resistance. Or let's say that I want to solve for resistance. What I can do is just put my thumb on top of the R, and I'm left with R is equal to voltage on top of current. So it's pretty straightforward like that. We have these three formulas. These three formulas we're going to be using quite a bit. And if you get into basically any physics classes, in high school or college or beyond this, you're going to be using Ohm's law a lot, especially anytime you work with circuitry. Now, in the video we talked a little bit about George Ohm. Interesting, he was a school teacher, and he's the guy who discovered the relationship between voltage, current, and resistance. Now, you should have all received a worksheet, a packet. It's a quite a lengthy assignment. Well, I guess there's 18 questions, but there's a few questions like I'm looking at it right now, number 12 that has about 4 parts to it, and number 18 that has about 4 parts as well. Let's talk about that worksheet for a second. If you look at the front page, I'll give you an example. It says if a toaster produces 120 ohms of resistance in a 120 volt circuit, what is the amount of current in the circuit? Okay, so I'm looking at the front page. I want you guys to all do that. Let's take out the Ohm's Law practice packet if you're not there already. On the front page, there, underneath the word example, this is where I'm looking at. It says if a toaster produces 12 ohms of resistance in a 120 volt circuit, what's the amount of current flowing in the circuit? We can solve this equation quite easily. All right, we probably don't even need a calculator for this. Now, first thing we need to do is just figure out what information do we know. Well, we know the amount of resistance. There's 12 ohms of resistance. All right, so we know that R equals 12 ohms. And we also know that the voltage is 120 volts. So we know that voltage is equal to 120 volts. All right, what are we solving for? We're solving for current. And the way I usually solve these guys is I will circle what I'm solving for, or maybe underline it. I try to make this easy for you when you see the rest of your questions. I boldened the thing that you have to look for. So we're solving for current. So when we're solving for current, we have to choose the correct formula. All right, so I go back to my triangle here. I always draw this on the top of my worksheet. V is equal to I R. I know that by putting my thumb over this, I can see current is equal to voltage over resistance. Okay, so I have to go to my toolbox of formulas here. I use this thing. I cover up the I, and I can see that I is equal to voltage over resistance. So now I just start plugging in the variables. I know that the R is 12 ohms. And then I know that the V I have up here, the V is equal to 120 volts. So I could say quite easily here that the current is equal to, I just take 120 divided by 12 equals 10. Now I have to have the correct unit of measurement. And I'm solving for I. I'm solving for current. A single unit of current is amps. So I can just put down an A for amperes. So that example question there, I could say that the toaster has a current of 10 amps. All right? Now that's probably the easiest, one of the easier ones you're going to do. I wanted to, since I'm not here today, I wanted to show you probably one of the hardest ones. All right? One that I kind of expect a lot of people are going to have some questions on. I'd like you to turn to question number 14, please. If you look at question number 14, so why don't we, if you're not there yet, go ahead and go to this, please. It says, in your own words, state the relationship between resistance and current in a circuit. That's kind of tough. All right. So what we have to do is we have to do a little test, a mathematical test, to determine what the relationship between current and resistance actually is. So I'm going to do two questions here. I'm going to change my ink color. I'm going to make two test equations. I'm going to go with test equation number 1, test number 1, and over here I'll do test number 2. All right, and basically what I'm going to do here is I am going to plug in two different amounts of resistance, but I'm going to plug in the same amount of voltage. And let's just see how it affects current. So here we go. In test equation number 1, I'm going to solve for current, and I know that current is equal to voltage over resistance. I'm going to use that equation over here as well. Voltage is equal to, current is equal to voltage over resistance. In test question number 1, or in test equation number 1, I'm going to put down I'm going to be using 12 volts. I'm also going to use 12 volts over here. But what I'm going to do in test number 1 is I'm going to use 3 ohms of resistance. Now here's where it changes. In test number 2, let's try to increase resistance. I'm going to raise it up to 4 ohms. All right. And I just solve this, and I could tell that in test equation number 1, my current is 12 divided by 3. That's going to be 4 amps of current. Now let's see what happens when I increase the resistance. In this case, I have 12 divided by 4. That's going to equal 3 amps. So my answer would be, and I'm not going to write this out because right now I'm drawing with a mouse. It would be really hard to write this out. But my answer is that when as illustrated in my two tests, raising the resistance, as I did here, raising the resistance actually lowers the amount of current. So what is the relationship between resistance and current? The relationship is this. When resistance goes up, current goes down. Okay, so let's talk about the assignment here. You guys have the rest of the class to work on this. All right, this is due on Monday, start of class. All right, now some of these questions are going to be difficult. All right, there's 18 questions. I know we're not all math geniuses, but I'm confident you guys can solve these questions. All right, main things I want you to know. 1 is do this on a separate sheet of paper. Okay, answer these questions on a separate sheet of paper. And 2, make sure you go the extra mile here. Okay, use your units of measurement. And mostly, some of these questions are going to seem hard at first. You have to think about them a little bit, but I'm confident every one of you guys can do it. All right, this is going to be due on Monday at the start of class. And make sure if you have questions, talk to the substitute teacher, because I gave her an answer key. I'm sure that she could kind of help guide you in the correct direction. All right, guys. I'm going to go ski now, so we'll talk to you later.